let me take you through combined focal length. Combined of two lenses in contact. So I'm going to have lenses in contact. I have this lens. This axis. This is A, this is B. This one having F1, having F2. Then an object. We know that this object is for A. So A forms an image here. But it worked as a virtual object for B. It worked as a virtual object for B. Then what does the B do? The B converges. So the B will converge like that. Form an image here. I. So we shall now say from here, the middle, we shall say this is our U, okay? This is our V. Then here we shall call it V what? V prime. So action of A, action of A, 1 over F1 equals 1 over U plus 1 over V prime equal to 1. Then from there we go to action of what? Action of B. We shall say 1 over F2 equals 1 over. Now action of B, our U becomes what? Our U becomes negative what? Negative V prime. Because this one acts as the object of this lens. Okay? So to be 1 over U, which is V prime, negative V prime, plus 1 over V. Then this equation of 1 plus 2. We shall say 1 over F1 plus 1 over F2 should give us. So when you add, what do we get? 1 over this one will disappear. We shall have 1 over U plus 1 over V. But we say for combined, for the combination, for combination, 1 over F is equal to 1 over U plus 1 over V. Therefore 1 over F, okay? 1 over F, let me write it here. Therefore 1 over F, capital F, is equal to 1 over F1 plus 1 over F2. NV. This one can also work for when you have two lenses in contact. It can also work when you have two lenses in contact, okay? It can be a converging lens with a converging lens or a converging lens with a diverging lens. But you cannot have a diverging lens in contact with a diverging lens. You understand? So it can work for converging for this kind of arrangement, or it can work, or alternatively, it can work when you have this kind of arrangement. You see that it can work. Okay, see? So that you have an object here. Now this one giving rise to the image which is I what? I prime. I see that? Then this one, that's what? Divergence. Divergence to give rise to I. So that this is U. Then this one will become what? This one will become B prime. Then the final image is this one, so it becomes V. But this one, so that now the focal length for this one is F1, the focal length for this one is negative F1, F2. So you can go through the same steps like this one, okay, keeping in mind that this is a negative f2. You get the point, eh? The rest will become the same. Okay, you can even take it, but it is better to take a negative because you know the principal focus of this one is always virtual. Then we can now move on. We can look at the full thin length formula. Full thin length formula. Okay. So in this case, we are going to consider a parallel beam of light. Consider a parallel beam of light. I will not write those words, but when you write them, make sure you write them. So I have this. Then it converges through the what? This is F. Meaning this is our F up to here, and then this is our H. This is our deviation, which is same deviation is here. So we shall say that for small angles, what? For small angles in radians, we shall say tan of D is approximately equal to D, which is H out of F, equation what? 1. Then we consider, let's consider, we know that the lens is made up of small prisms. Is made up of small what? Prisms. But for small prisms, for small what? Prisms, deviation is given by n minus 1 times a. So that means that n minus 1 times a should give us h over a fraction. This is not really 1. So that implies that this means that our a will become h over n minus 1 times a. The equation what? 1. Then after that, we can also consider this one. This is a lens. Let's say, let's consider something here. Make sure you are very careful. Now, a lens has two curved surfaces. So this is the first curved surface with its center of curvature C1 being this one. Then this one has also the curved surface, the center of curvature being C1, C2. So we know that line is passing through the center of curvature, they strike the surface normally. So this one is going to strike the surface normally. Like this. So this is it like that. Then this one is also going to strike the surface normally. Like this. So this is 90. But then this, we are saying that when you produce this one like this, let me see. When you produce, it is like a prism. It's like a prism. It is like a prism. It's like a prism. This angle here is refracting angle A. Is refracting what? Angle A. And we know that in a prism, if you have this a prism, and you have this, you have a normal. And you have a normal here. This angle is A. The angle between the normal is also what? A. So where is our A? Our A is this angle. This angle is our A also. This angle is A, and this angle is also what? Is also A. Now let us say this is H. We call this one alpha, this one beta. Then we say the distance from here to here. Radius of curvature R1, the distance from here to here. We call it radius of curvature R1. So that we shall now see. The sum of two interior angles, that's alpha plus beta, should give us one exterior angle. Okay? Now, for small angles, what? For small angles in radius, we shall now have tan of alpha approximately equal to alpha, which is h over r1. Tan of beta equal to beta, which is h of r2. This is equation what? 2. Okay, so equation 2 becomes equation 2 becomes so that is h over r1 plus h of r2 is equal to that's equation what? 3. Then from there, you can say from 1 and 3. Can I write here? I said from 1 and 3. From 1 and 3. From 1 and what? And 3. So we can now say that h of r1 plus h of r2 is equal to h over n minus 1. So h will cancel. So when h cancels, we shall have 1 over r1 plus 1 over r2 is equal to 1 over n minus 1 f, like that. So 1 over f becomes what now? Becomes n minus 1 with 1 over r1 plus 1 over r2. Very important equation. Very important what? Equation. So that is full thin length formula. Full thin length formula. So then we shall now say sign convention. Or the radii of curvature. Sign convention for the radii of curvature. So, if the surface is convex, if the surface is convex, then R is positive. If the surface is concave, then R will be what? Is negative. If the surface is plane, then R is infinity. R is infinity like this. That's the for infinity we shall use. R is infinity. Okay? So we shall use this sign. R is infinity. So i.e. So R is positive. Here R is positive. Okay? Then R is negative. R is negative. Next. Then the other one, if we have this, R is positive, R is equal to infinity. Okay? If I have this, R is positive, R is what? Is negative. And etc. and etc. If I have this, R is negative, R is equal to infinity. And if I have this, something of this nature, let me say, I think the rest is okay. Yeah. Then if I have this is a concave side, this is a convex side, like that. So, and if the lens is surrounded by air, then we shall get reflected 1 over f is equal to N of grass over N of air minus 1 times 1 over F, actually 1 over R1 plus 1 over R2. For another medium, e.g. water, if the lens is surrounded by another medium, e.g. water, we shall say 1 over F, the focal length of the lens will be equal to N glass over N water, the focal length of water minus 1 into 1 over R1 plus 1 over R2. Where R1 and R2, they are radius of curvature or radius of curvature of the lens surfaces, okay? The lens surfaces. So we look at examples. Let us look at examples. Number 1. Examples number 1. Examples number 1. Examples number 1. Okay, we are going to have these two examples. I hope you are seeing, you'll see them. I want to make sure that everyone who will watch this video has been helped and you find this video so interesting and you'll be able to just excel with ease. So, number 1 says a converging meniscus with radii of curvature. So this is a converging meniscus. So converging meniscus, how does it look like? So a converging meniscus is this. This is a converging what? Meniscus. That's a converging what? Meniscus. Now, this one has wider radius of curvature, so R will become 15 with radius of curvature 15 centimeters. That's R1. Then R2 will become 6 centimeters. This one is so much curved. That's the bigger radius of what? Curvature. Then they're asking us, the effective index N of glass is 1.5. So the question goes, calculate its focal length when surrounded by air. So when surrounded by air, 1 over F is equal to N glass over N air minus 1 into 1 over R1 plus 1 over R2. So, but then, the fact index of air is 1. So 1 over F is equal to N glass minus 1, okay, into 1 over R1 plus 1 over R2. Then we substitute, this is 1.5 minus 1 times 1 over 15. In right, we don't convert. In the right, we don't convert, plus 1 over 6. So that's 1 over F. Remember, 1 over F is the power. Sometimes they can ask you the power of the lens. But 1 over F is what? Is the power. So our F, when you use calculator, you will be able to get your F as 20 centimeters. So that is example number 1. So the part 2 says it is surrounded by liquid of effective index that. So if it is surrounded by liquid, what is going to be our formula now? Okay, we shall say part 2, 1 over F equals any gas over any liquid minus 1 into 1 over R1 plus 1 over R2. So we substitute 1 over F will now become 1.5 divided by 1.2 surrounded by liquid of effective index 1.2 minus 1 into 1 over 15 plus 1 over 6. So our F will now become, if you use a calculator properly, you'll be able to get your F as 40 centimeters. 40 centimeters. So that is part 1. Now, you can also go ahead and do number 2. Number 2, I hope you see number 2. I see number 2. So can you go ahead and do number 2. That is just assignment for number 2. Is that okay? Assignment for number 2. Okay. Then let's move on. We want to look at determining refractive index of the liquid. Determining refractive index of a liquid using a convex lens and a plane mirror. So now, how do you do this? Okay, now they have not told us that the convex lens is of known focal length. The focal length of the convex lens is not what? Known, isn't it? Now, what I want to do, we need to first get the focal length of the convex lens. How do you get it using a plane mirror? So we expect you to tell us. First, draw this. Then this. Then here we have this. We have so the objective image I. Here we shall call it F1. So now we expect you to do this. You say a convex lens. That's point number 1. Say a convex lens is placed on the reflecting surface of a plane mirror. Next, number 2. A pin is clamped vertically above the lens, such that its tip lies along the principal axis of the of the lens. It is then moved up and down until it coincides with its own image. The distance F1 is measured and recorded. Remember, this is the focal length of what? Of that. Now next diagram. Another diagram. We have this. The lens is here. So we put it here. Here we shall call it capital F. Because capital F. Now, you see when the lens is placed on the liquid, the liquid behaves like what? Which are like a concave what? A concave lens. You see that? It's a concave lens, but it's a plano-concave lens. You see that? Plano-concave lens. So meaning that the upper the surface of the lens, the radius of curvature of the lens will be the same radius of curvature of this liquid. Okay? So we have now gotten F1. Then we say that the space, next point. Okay? After the diagram, next point, we say the space between the plane mirror and the lens is smeared with a small quantity of liquid, whose refractive index is to be determined. Whose refractive index is to be what? Determined. Then we say the pin is again moved up and down until it coincides with its image again for the second time. Then we say the distance F from the pin to the plane mirror is measured and recorded. Remember, this is the distance of combination. Then from there, say the focal length of the liquid is what from? The focal length of the liquid is what from? 1 over F1 plus 1 over F2 is equal to 1 over F. So 1, this is the liquid. This is a glass. Okay, let us call this one K. So meaning that 1 over F of liquid will become 1 over F. Okay, minus 1 over F glass. The focal length of the liquid is what from? 1 over F liquid equals 1 over F, combine it, minus 1 over F. Then after that, you say that since the liquid is in contact, that's the next point. since the liquid is in contact with the convex lens, the upper surface of the liquid takes up the radius of curvature of the lens. Meaning that if the radius of curvature of the lens is 10, also this for the liquid will have what? 10, then here it is infinity. That's all. Then we say the refractive index of the liquid is equal to 1 over F liquid is equal to N of liquid minus 1 into 1 over R plus 1 over infinity. Why is it infinity? Because down here we have this kind of what? So this is R, which is negative, this is negative, then R is equal to infinity. Then we substitute 1 over FL will become N L minus 1 times 1 over negative R. So negative R over FL will become N L minus 1. So meaning that NL will become 1 plus, okay? 1 plus, comes here plus, 1 minus 1, okay, minus R over FL, like that. So that's what we have. So the factor index of the liquid can be obtained from that. Can be obtained from that. Or you can take a positive. If you take a positive, then it becomes plus. Let's take a positive because even the focal length of the liquid will also be negative. So negative will disappear and you get what? A positive. So let's go back reverse. We say we start from here. We are looking for this the focal length of the glass. We don't have it. So you say that a lens is pressed on the reflecting surface of the plane mirror. A pin is clamped vertical above, such that its tip lies along the principal axis of the lens. It is moved up and down until it coincides with its own image. The distance FG is measured and recorded. Let me say the space between the plane mirror and the lens is filled with small quantity of liquid whose refractive index is to be determined. The pin is again moved until it coincides with its own image. The distance F, capital F, they are combined. The distance capital F is measured and recorded. Then you say the focal length of the liquid is got from 1 over FL is got to 1 over F minus 1 over FG. Then after that you say the refractive index of the liquid is now got from NL equals 1 plus R over FL, where R is the radius of curvature of the convex lens. So that's brief how we can see. These things you don't write them. I mean, when you're explaining exams, you don't go through the equations. You are not supposed to write the exams. You just quote the final equations, okay? But for purposes of understanding, in your book, you must have all these things. For the purposes of understanding, in your book, you must have all these things. I hope you'll be able to write notes of your own notes, okay? Yeah. Then let us look at now. We can go ahead and say NB. We are saying that it can be seen from the experiment that the liquid lens is the plano-concave type, with each lower surface corresponding to the plane surface and upper surface to the convex lens. Therefore, R1 is a negative, is the radius of curvature of the upper surface, and R2 is infinity, the radius of curvature of the lower surface. Is that okay? Then we can go ahead and look at the examples. Go ahead and look at what? Examples. Go ahead and look at what? Examples. Examples. So, we are going to have examples. Example number one. Example number one, we shall have this. We shall have this example number one. Number one shall have that example. Okay. So what does it say? What does the example say? A converging lens is pressed on top of a liquid So we have the liquid is here. So the converging lens is here. So this is the liquid here. So converging lens is placed there using a pin O. The position is found where O coincides with its image. So image is here, and they are giving us the radius of temperature as 15 centimeters. And the refractive index of the lens is N of the lens of the glass is 1.5. So let us first get the focal length, because the focal length of the lens will help us to get the focal length of the what? Of the liquid. So focal length of the lens, we shall say 1 over F of glass is equal to N glass minus 1 times 1 over 15 plus 1 over 15, because it has, okay, this is R1, R2. So this is 1 over FD will become 1.5 minus 1 times 1 over 15 plus 1 over 15. So 1 over 15 will now become, this is 0.5 times, this is 2 over 15. So our FD will now become 15 centimeters. So they are saying that determine the position of coincidence. Determine the position of what? Coincidence. For the request of the liquid, for liquid, we shall say 1 over F of the liquid is equal to N liquid minus 1 times 1 over R. R1 plus 1 over infinity. So here we shall have 1 over F of the liquid giving us 1.4 minus 1, then times 1 over 15, because the second surface here, this R here is infinity. So here we shall have 1 over F will now become, this is 0.4 times 1 over 15. So what do you get? What do you get? 0.4 times 1 over 15. Here we shall be able to get something like okay, we don't have, let's take it as 1 over F as 0.4 over 15. Yeah. Then this is a liquid. Now, but then we say that when they are combined, when they are in contact, the focal length becomes capital F, which is a combination. So they coincide at the point, okay, where there is focal length for the what? Combination. So we shall say for combination, 1 over F equals 1 over F1 plus 1 over F2. So 1 over F will now become 1 over F1. FD is what? Is 15 plus 1 over 0.4 over 15. So 1 over F will now become, we add 1.4 over 15. So F will become 15 over 1.4. It is always less than the focal length of individual lens of the lens, which we shall be able to get 25. I think we shall get 25 centimeters. Okay, every time you can get it. Yeah. It is 25. Okay, 25 centimeters. Okay, you can get it and see what you get. I think it is likely to be less than that. That one might be having some mistakes. That's example number 1. Is it okay? Now example number 2. Can you go to? Now this one will be exercise. This one will be exercise, research work. Okay. Then I can go to example number 2. Example number 2 is here. Example number what? Number 2. That's example number what? Number 2. So this example number 2, what does this say? Example number 2 says a thin equiconvex lens of refractive index 1.5. So they've given us the refractive index, okay, and it is okay. I hope you remember, if we say equi, what is the shape of that glass? What is the shape of that? Equi means that both sides are what? Are equal. Both surfaces are equal. So they have given us the fact index. I think the convex length of the fact index of the glass as 1.5. Radii of curvature 24 centimeters. It's based horizontal on plane mirror. So put it on the plane mirror. When the space is filled with the liquid, so we don't have this F. F of the glass is not given. When the space is filled with the liquid, when the space is filled with the liquid, when the space is filled with the liquid, the distance here is what? The distance is 40 centimeters, which becomes capital what? Capital F, because this is combination. That's capital F, this is the combination. Then I say, find the fact index of the liquid. Find the fact index of the liquid. So 1 over F of the liquid is equal to N of the liquid minus 1 times 1 over R. Because the second R is infinity 1, because the lower surface has no radius of curvature. So here we shall now be able to get, but then we don't have this one, we don't have focal length of the liquid. Now for the glass, let me see for the glass, for lens, 1 over F of glass is equal to 1 n minus n glass minus 1 times 1 over, since it is equal, that's R, 1 over R, 1 over R plus 1 over R is 2 over R. 2 over R. 2 over R. So 1 over F of glass will now become n glass, which is 1.5 minus 1 minus 1 over 22 over 24. So 1 over F glass will now become 1 over 24. Then from there we go to combination. 1 over F equals 1 over F glass plus 1 over F what? Liquid. So 1 over F liquid will become 1 over the focal length combination is 40 minus 1 over 24. So what? So 1 over F will now become what? So in this case, the focal length will now become, it will now become, let me see, okay, I don't have the answer, I didn't work it out, but you can work it out and see. Okay, when you work it out, it will give us negative 1 over 60. Negative 1 out of 60. Then after that, we come and say, therefore 1 over F of the lens is equal to, sorry, of the liquid is equal to n minus 1 liquid times 1 over R. So this is negative 1 over 60 is equal to n minus 1 times negative 1 over 24. Because it has the radius, this is a concave lens. It acts as a concave lens having a virtual radius of curvature. So this is 24 over 60 is equal to NL minus 1. So it means that NL will become 1 plus 24 over 60. I think it will give us 1.3 something. Here we shall be able to get 1.4. So the last I have just said that the exercise, this one will act as the exercise. When you go through the work, you can be able to do these numbers. Okay. Of course, I'm hopeful that you'll find it very interesting, very enjoyable, and you'll be able to understand. And after that, I'll just encourage you and advise you to always go to the question bank and check out the related questions and see if you can use the knowledge acquired to handle those calculations. Now, other than that, for that, we can now say we pause there and we'll add later.